Right. So does anybody know what a vector is? Let me hear. Does anybody know what a vector is? From physics. Physics students. At least supposed to know what a vector is from physics.
Is a quantity having direction as well as the magnitude, especially as determine
You reading
something,
that from
something.
Google. You reading that from Mr.
Nah,
Google.
nah, being real with you, recently start vectors in school and all too. So finally we doing some, nah, but I
Something
really can't
it,
remember
it
though.
should be doing.
Yeah, yeah,
So,
but that is what I remember. I do remember the rest. Where
all
he
right.
was telling me about something, so something like that.
So a vector is any quantity or object that has both size. Another word for size is magnitude, by being simple with you guys. So a vector is any quantity or object that has both size, magnitude, and direction. And the types of vectors we are going to look at is vectors in the Cartesian plane. Basically, vectors in the 2D space. That's the XY axis. So we're going to look at vectors. We are going to deal with vectors in the Cartesian plane. You could also call the Cartesian plane R squared. Right. So let me explain something. You're probably wondering, what does man mean? Has both size and direction. Well, Kiara, you could give me an example of a vector in physics. Kiara, anybody give me an example of a vector quantity in physics? Anybody?
Um, Forces.
A force. Let me explain something, right? So under vectors, we're going to look at this example. And an example of a vector is actually a force. Example, a force. Price. I'm gonna ask that question, right? Let me just draw Aliyah. Let me just say Aliyah eat too much food now and she get fat, right? Yeah.
Dole she said that to the
So Aliyah gonna eat too much curry from the pot. Now she gets a little fat, right? A little fat.
the
She get bigger than you.
ah
So this is Aliyah over here.
mm-hmm.
And let me just say she said I want she stand up in front of the TV and she blocking the TV. Right? She blocking the TV. With your big self.
Mm-hmm.
I joking, I joking. And this is you over here, right? This is you over here. As I
Mm-hmm.
said, she get she eats a lot, like plenty,
Yeah.
and she blocking the TV, and she could push her in this direction, away from the TV.
Yes,
So when you're pushing her, you're exerting a what on her? That's with F.
of course.
You're pushing her with a force, and the force has magnitude. Force is measured in newtons. So let me just say you're pushing her with a force of 100 newtons in this direction. Okay?
Yeah.
But what if you was pushing her in this direction? What would happen is the force wouldn't change, just the sign would change because you're pushing her in the other direction.
Different direction. Yeah.
So force is an example of a vector because you could push somebody in both directions, right?
Yeah.
So force is an example. You can have negative forces. It just indicates, Keely, you understand that? A force is something that has size and direction. If you push somebody, you're pushing them with a force. It had to have some size and it has some value to that. But depending on how you push them and what direction, that will determine the sign. So you can have negative forces. It just indicates the direction. So let me give all you a situation. Let me just say you have a block over here. If you're pushing the block in this direction, let me just say you're pushing the block in this direction, that might be 5 newtons, right? And let me just say you're pushing the box from the other direction with a force of like 7 newtons. But Amy, since 5 newtons, since it's positive 5 newtons, you're putting the force in this direction. What do you think? How do you think I would write the force in the opposite direction? Leave it as positive or change it to negative? Amy? So a force of 5 newtons is positive in this direction. So you think 7 newtons would indicate this direction, it will indicate this direction. One or two. Amy, there? I'm gonna figure out now.
Sorry, my mom was in my room. Anyway, the first one.
The first one, right? So 7. So you think 7 newtons representing it going in this direction? According to what we see in here, 5 newtons, if it's positive, that means it's going in this direction. So should 7 newtons point in this direction or should point in this direction? This direction, right? Because if it's positive, it's pushing it to the right. So what I would have to do is I would have to change the sign, change the sign. Because the sign shows what direction you're pushing the box in. You understand?
Yeah.
Okay, Sasha, let me explain that for you. If you push something, let me just draw the axes here. I'm just gonna draw X and Y axis. By the way, we call the Cartesian. If anybody confused what the Cartesian plane is, because I'm using big words, the Cartesian plane is just the X and the Y axis. That is literally it. So Sasha, what we gonna have here? X or Y? X or Y? X or Y go in here.
Y.
Y go in here. And then X go in here. So we call this the Cartesian plane, and it is a vector space. The vector space is the space where you're going to put all the vectors. Now, Rihanna, I have a question. If I go in this direction, you think my sign will be positive or negative? If I'm going in this direction, my sign going to be positive or negative?
Positive.
My sign going to be positive, right? Because I go in the positive direction. Bryce, if I go in this direction, how would I indicate that? Positive arrow or negative?
Negative.
Right, because I'm going in the opposite direction. Anytime you go in the opposite direction, you have to change the sign. Paul, note for that, note for you all on the side. Anytime you change in direction, note. Anytime there, they only know about one direction, aren't they? Anytime there is a
There is no 5 directions, not one direction anymore.
all of them splits. So anytime there is a change in direction, you must change the sign. Anytime your friend can fake, you gotta delete the numbers. You gotta change the digits. Gosh, do that. Don't be toxic like that. I feel that's something Aliyah might do, you know.
We,
Aliyah not
really?
here. Aliyah not here to hear
Nah,
we.
nah. Yo, of course you. Of
No, no, no.
course you. Of course you. All right.
Anytime there is a change in direction, you must change the sign. Come on, if people changing up on you, yeah, it can't be moving the same way with them. You had to change your sign. You had to take that as a sign. You must change the sign. Okay, we have finished with the example as yet, right? Um, Haley, Haley, if I go in this direction, positive or negative, I would indicate that direction was positive or negative.
Positive.
Okay, if I go in this direction,
Negative.
okay, if I go in this direction,
Positive.
if I go in this direction,
Negative.
right? So you understand what I mean, right? And all these arrows, they would have a length. Wouldn't, isn't that so? And I can measure the length,
Yeah.
but the sign for them would be different because they're going in different directions. That's an example of a vector. You understand that real good?
Yeah.
Cool. Um, Give me a moment. Okay, want some time to copy down somebody notes?
Yes.
Okay. And we refer to this as the Cartesian plane. I use more fancy terminology from university here. I currently doing vectors in UE in maths, but like the vectors are a lot more complicated. But the terms still hold, so it could seem very smart. Granted, you all are very smart, and Haley, and so you know how to fake, and so you're actually smart.
Yeah, boy.
Yeah, yeah, yeah. So we call this the Cartesian plane, and this is going to be our vector space. Vector space, and since we're dealing with the Cartesian plane, that is r squared, meaning we're dealing with two dimensions, right? So at this level, all you just had to care about, okay, you're going left, you're going right, you're going up, down, that kind of thing. Cool. So you all could copy this down here. Rihanna, let me know if you understand everything I do.
Yeah, so far.
Cool. Sasha, you understand everything I do?
Yeah, I done write down everything too.
Okay, cool. Oh, you know what I should do, guys? I should get a picture of Vector, and put him over here. I will do that. So you
You
know,
know, when you say that, I was looking for a sticker of him because I had one and I not finding it.
here what? If you find the sticker, I'll put him. I'll put that exact sticker over
All
here.
right, all right.
It's have a youth man that is lying between school, right?
You
And
bet.
and you know the Air Forces.
Oh yeah, yeah,
But this man have one fake one now, where so instead of forces, we telling me just be wearing vectors.
yeah. Wow. I find like Vector does look like a coolie boy from South named Raj. Not Rajiv, Raj. Raj.
Yeah, Rajiv.
What is it?
Yeah, Rajiv.
No, 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 no. I'm actually Vector real smart, you know. Vector real smart. He just invent real things. Right. So as soon as I have this copy down, let me know. Move on to some other concepts. I will actually show you how to represent vectors in the vector space, R squared. So, Amy, vector space, right? What vector space means is just the place where you're gonna put the vectors. That's the x and y axis. Simple, right? That's simple. Let me know if you understand that. When I say vector space, I just mean the place where you're gonna put the vectors down.
Yeah.
And I'll go see what vectors are. Vectors, you can think of vectors like directions to go to a point. I'll write it down. I'll make a note of that somewhere.
I'll find this sticker.
Send it. I'll pay it on one time.
Send it on the group or send it to your personal.
Send it on the group. Because I mean it will be on the screen, so you know.
Alright.
Also, good evening, Kirsten. Kirsten, if you're able to talk, it could say hello and thing. And you just feel a little shy. Did you do vectors in school as yet? Yo, what do you have? My God. My God, Bryce.
So I do even remember how I made that do. I really even know.
My God. Here what? I'll still put the sticker, right? It'll make the notes memorable. They wouldn't forget it. But in all your maths exam, please don't draw a picture of vector if they ask you what is a vector. If I was the marker, I'd give all the full marks, but don't don't do that. Rihanna, if you was a maths marker, if you was marking a maths paper and somebody they ask you what is a vector and they draw a picture of vector, what you gonna do?
Uh, not the vector I'm looking for.
So you get them it wrong.
Well, duh.
Wait, Rihanna is a buzz skill boy. Wait, Rihanna. Dread, yes? Rihanna dread out here, yeah? Wait. Rihanna not here to play no games. Also, we missing Desron or somebody loud him up on the chat. Call him loud. Say, hey Desron, where you there? Desron's supposed to be in class. I find he dilly-dallying too much. Somebody gotta load him up. Rihanna, that your buddy. Sort it out. Worship a vector. Worship a vector, guys.
Next to the head.
Over here. Oh,
Yeah, right here. Nah, next to yeah.
They're looking kind of weird. You should put him on the center. Like over by the note. You should put it by the note. Or under the note.
we have idea.
Yeah.
Right. I saw someone like I'm take picture of this and put it on Instagram. I saw. Ah, right. Cool. So we know what a vector is. I'm gonna for you copy down everything.
Nah, you can zoom in. I can't really see it now. Almost. Yeah, that's good.
Are you understand my handwriting? Amy, you understand? You understand my handwriting? My
Yeah,
handwriting all scrappy
I
these days.
find it looking normal.
Hmm. Hmm. Amy, when you do your add so monkey go submit ASAP, right?
Oh, yeah, yeah, yeah.
ASAP Rocky. Oh, this isn't the ASAP Rocky. Do you know who that is?
Of course.
Nice. Yeah. You all have it copied down? Let me know. Up to this point?
Wait, I know which one we are going to.
Yeah, that's it. Yeah, you gotta write fast. Rihanna, which part do you reach? Can I
I
hear Rihanna?
finished.
Where did you reach?
I say I finished.
You finished? Like the diagram and everything with the Cartesian plane? No,
Yeah.
Rihanna. All I wanna say about my baby cousin. Wait, why you getting your head for? What you doing? Sasha Rianj, shit in the head with my hand. Yeah, say hi to them. Say hi, Ranch. Ranch, you okay?
Eat this. Eat it.
Say hello. Say hi, Rihanna. Tell her hi. What you doing? And then jump on the chair.
Now I try to.
Tell them hello.
Hi.
Ranch, you getting licks?
Tell auntie I say hi.
Is this pajamas? Okay, okay. Okay.
All right. I'm gonna move down to the diagram because we gotta move on. So 5 minutes to copy down this piece. Amy, you have all of this copy down. Haley, Sasha,
Yeah.
Yeah.
the only person that don't have this copy down is Bryce.
Which part?
This part over here with the
No.
Oh yeah, I have that.
Yeah.
Finish it.
okay. What I'm trying to say is you need to know that up is positive, down is negative, left is negative, and right is positive.
Yeah.
Right. This boy real loud, yes. So we're looking at the syllabus. What we just now did was explain the concept of vector. We need to look at the magnitude, unit vector, direction, scalar. So first things first. You all need to know what a position vector is. So I'm going to start off with something called a position vector. Before I do that, let me just explain something. So note, you can think of vectors like directions to go to a point. So let me give you an example of what I'm talking about. Right. So, Rihanna, I want you to read what I wrote there. The note.
You can think of vectors like directions to go to a point.
Yes. Let me just actually write point, because I feel like some of you guys will not know that that means point. And what typically happens is you always read it as the horizontal component first, then the vertical component. So you can think of vectors as directions to go to a point. It typically looks like this. So let me start off with this vector called O to A. Now vectors take this form. Typically, this is the form vectors take. Vectors would typically take the form, open bracket, X, Y. What the X stands for is how you're going to move horizontally. So the horizontal movements. And what Y stands for is the vertical movement. So that's what a vector typically looks like. And I'm going to give you an example. So you can think of vectors like directions to go to a point. You're going to take the horizontal movement first, and then you're going to take the vertical movement. So the first thing we're going to start off with is something called position vectors. So a position vector is a vector that starts from the origin. So we're going to look at position vectors. All right, and I'm going to make a little note to the side explaining what I mean. So, Katie, yeah, you're now seeing this for the first time, right? Vectors. And this is
Yeah.
notation. Cool. So let me just say that this is Pinal, this is San Fernando. Actually, no, let me just say that this is Pinal, this is Sando, and this is Port of Spain. If I want to go from Pinal to Port of Spain, wouldn't I have to move some distance horizontally and then some distance vertically? Tell me that makes sense. If I want to go from Pinal to Port of Spain, and I had to move some distance horizontally and then some distance vertically.
Yeah.
So we call that a vector. Like I said, a vector, you can think of a vector like directions to go to a point. So that vector would be given by this line over here from Pinal to Port of Spain, and you have an arrow showing the direction. So this is a small example. So this over here, this is your horizontal movement. And this over here is your vertical movement. Right, so let me give you an example. If the first set of examples we're going to look at is position vectors. All that means is the vector starts from the origin, 0, 0. You all need time to copy this down? Let me know.
Yes.
Okay, take some time to copy it down. So, Rihanna, according to what you learned so far, a vector has size and magnitude. So it tells you the size of something and it tells you the direction it should go. Does that make sense? It tells you
Yeah.
it tells you the distance and it tells you the direction you had to go. So if I tell you, hey, go by Roti or the road, I can tell you, walk in that direction and it's approximately a couple meters. I might say that.
Yeah.
That's an example of a vector. That is literally what a vector is. A vector has two parts, horizontal and a vertical. Because if you had to move somewhere, if you have to move somewhere in the vector space, you could move, you had to move to the left, then up, you can move to the left, then down, so on and so forth. So how you move in the vector space is gonna be vertical and horizontal. Does that make sense? Like,
Mm-hmm.
so you on this space here, you're on the Cartesian plane, you could move to the left, you could move up, you could move to the right. Right, some of that makes sense. And over here, and on the Cartesian plane, you could move to the you can move to the left, you can move to the right, you can move up, you can move down. Does that make sense?
Yeah, it will literally you could basically move anywhere.
You can move anywhere, but we governing it, well, we defining it as a horizontal movement and a vertical movement.
Mm-hmm.
That's what we're gonna consider. You're moving to the right, moving to the left, or you're moving up or down. Understand?
Yeah.
Right. That's how we're gonna look at it here. For instance, if I tell you to go buy something from out the road, and somebody might tell you, well, go out the road, and the place is to the left.
Yeah.
So what I mean was, you'd walk out the road, and then you would go to the left. You know, that's an example of a vector.
Serious.
Yeah, because you would walk some distance, and that distance would have a size,
Yeah.
and then to how you walk, it would be in a specific direction.
Yeah.
It's a vector. Literally a
Okay.
vector. And then you move, watch, and to go out the road, you move horizontally or vertically to go out the road. You move vertically,
Both
you move both, right? But to go out the road, before you even turn left, you move in what direction?
horizontal.
No, this is vertical.
Sorry.
You move up,
Vertical.
which is vertical, and then you move horizontally, which is
Yeah.
so a vector comprises of two components, horizontal movement and a vertical movement. You typically start off with the horizontal movement.
Yeah.
So I could copy that down. Sasha, we understanding everything so far.
Yeah.
Cool. Cool. Kirsten,
Oh, and Sasha.
you can't just
Yeah.
call out Sasha name so loud. You have to
Sorry,
say excuse.
sorry. Excuse, Asha. Excuse.
That's not very
Yo.
demure. That's kind of
All right. I'm very sorry because I'm very mindful, very new. But
mhm.
yes, anyways, excuse Sasha. Excuse Sasha.
Yo, what's up?
Yeah. Your hotel start coming out Wednesday, right?
Yeah, I don't see you now, tell him.
Yeah, yeah,
I'll send you the work after classes, okay?
yeah, no problem.
Um, I forget to ask Nicholas, you understanding everything I'm talking about so far with the directions?
Yeah, I pull out my physics notes from Form 3D and I remember everything.
Okay, cool. So all a vector is something that has size and direction. That's literally it. So as soon as all you have is copy down, just let me know, please. Please. Pretty
I
please.
finished.
Okay, Haley finish. Who else finish?
I finished too, but I had to do the line graph thingy whenever you scroll.
Okay. But I mean that's common sense. Like, up is positive, left is negative, down is negative, right is positive. You know that, right?
Yeah.
Actually, do you? From our last physics class, you confuse the up for left. Remember?
Listen, Reggie. Listen.
Miss
I
Miss
was not
Kiera,
in the
Miss
right mental
Kiera.
state. I was very exhausted.
Hmm. That is a scary mistake to make.
I don't know. I was watching the screen and my brain wasn't processing anything, to be honest, but
Yeah.
I understand.
All right. So you have it copied down. Amy, you're real quiet today. You have that copy down?
Yes, I finished.
Okay, I'm gonna trust that everybody have this copy down, right? So we're gonna move on to position vectors. So we know a vector, it carries you somewhere by taking a horizontal and then a vertical movement. So let me give you an example. So we're dealing with position vectors, which means we are starting from the origin. Does anybody not know where the origin is? Where's the origin, guys? Could somebody show me where the origin is? Fast. Anybody? Origin. Yeah, this is the origin. Okay, so we're starting from the origin, and let me just say that I want to go to this point over here. I want to go to this point over here. Could somebody tell me, in terms of the horizontal first and the vertical first, how would I reach from O to A? How would I go from O to A? And this is an example of a position vector because you're starting off at the origin. So let me hear suggestions. How would I go from here to here? What do I have to do? I'm up for suggestions. Remember, a vector comprises of a horizontal and then a vertical movement. So Bryce, come like you're given directions. So you're starting over here. How are we gonna reach to E?
What's that?
You wasn't paying attention.
Sorry. I want to do something real quick.
I will ask somebody who paying attention. You're supposed to be paying attention. You will
Sorry.
next question with me.
All right, no problem.
Healy, imagine you giving somebody instructions. So they're standing up at O and they want to get to A. How would you describe that movement? How would they go to A?
Um, I could use your example that you used.
Sure.
Okay, if A is superior and you're O DB, you could go from DB horizontally to penile and then vertically to Separia.
You make that sound way more complicated than it needed to be, but I get your point. So you're saying that I had to go in this direction, and I had to go in this direction.
Yeah.
Okay, well, describe that to
Mm,
me. Because I want to go from O to A. By the way, this is how we represent a vector. A vector is represented by a line connecting the 2 points you want to go to and an arrow in the direction. So I want to go to O to A. I want to go to O to A. How would I do that? Describe it for me in terms of numbers. So from O, I go into the right, I go into the left. What I doing?
you go into the right on the x-axis.
How much space is to the right?
5,
Nah, then 5.
4, sorry.
Right?
And then 4 spaces on the y-axis.
Correct. So I go in 4 spaces on the x-axis, and I'll be positive or negative.
Positive, both positive.
Both positive, excellent. And then I go in 3 spaces upright.
Yeah.
So
Uh,
so if I want to
yeah.
go from O to A, I have to move 4 spaces. I have to move 4 spaces to my,
Right on the x-axis.
I have to move 4 spaces to my right. And since I go into the right, that is positive. And then I need to go 3 spaces up. And that'll be positive. So look how I would write it. I would say that my vector, and when we write in vectors, this is how we typically write it. You write it like this. So your starting point, say ending point, and you put a direction. You put an arrow on top. So I want to go from O to A. So this is how I represent the vector. I write it. This is how I represent it. I could also write it as the common letter A. 2 different ways we could write a vector. And that vector would be equal. Here, remind me, when you're writing a vector, the vector must comprise of what 2 movements?
X and Y.
Right. So what was the X movement?
X is horizontal and Y is vertical.
Right. But what was the X movement here? What was the horizontal movement?
Oh, 4,
Right. And our vertical movement?
3.
Right. So our vector is just 4, 3. Simple, right?
Yeah.
Real simple. And if I want to write it, I could also write it as A, just a common letter A, 4, 3. Right? And both of these are valid. So that's how you would write a vector from a point. What do you say to that? Pretty easy?
Yeah.
Okay, nice. So Bryce, time to redeem yourself. Let me see if you was paying attention. Somebody give me a color. Give me another color to use.
Purple.
Purple. Remind me, guys, what makes a vector a position vector? The vector has to start from where? Where does the vector have to start from if it's a position vector? Where's the vector starting from if it's a position vector? Come on, guys. That's not hard. It's not a hard question.
The
Sasha.
origin.
The origin.
Yeah. Yeah. I'll take a little long there, you know. The origin. You start from the origin. Nice. So on this same diagram, I'm gonna put on a purple point here. That's not a circle, is it? Right? And Bryce, I want you to tell me how to go from O to, yeah, I want you to tell me how to go from O to B. And that is represented by this vector over here. Yeah, so how I going from O to B? Explain it to me like you're given directions. How am I going from O to B?
Okay, so okay, so hold on.
Why you laughing so much?
No, because Ali, I come out and was just doing random stuff. But anyways, um, you go in until -4.
Okay, so you had to tell me it in terms of direction. I go in
All right, so
four
you're
spaces.
taking a left, basically.
So I go in four spaces to the left.
Yeah,
And then what am I doing?
you go in 5 spaces up
Right. Simple, right? Real simple.
there.
So I go in four spaces. Wait. So I go in four spaces. And since we go in four spaces to the left, what sign are we going to use?
Negative,
Right? And then we went five spaces up. What sign are we going to use?
positive.
Right. And how would I represent that vector? When I say how would I represent the vector, I'm talking about like this, the notation for it. I would write that vector as what?
Um, five,
Look at,
4.
look at the notation. This is the notation. That's how we write vector.
For okay,
What point we
so
start at?
O
Right? So we're going from
B
O to B. To go from O to B, what was the movements? So O to B,
4 spaces left
so that'll be what? Positive, negative, tell me.
and negative
So -4.
and negative. Positive 5.
Right. And if you didn't want to write it like that, it's also valid to say, um, wait, it is also valid to say what, Bryce? I could write it like that, or I could write it as,
Um,
look at the notation for the previous question.
there was, I guess, 4 over 5.
Wait, look at it. Look at it carefully. So instead of writing O to A, I could have write a common A.
Okay, so I come on B then.
Yeah. And it can only do this for position vectors. Only for position vectors.
Okay.
That was one. Sasha, you understand this? Or like it hard?
I understand.
Cool. So I'll give all a past paper question then.
What year? Because I do in 2018 right now.
I go. I'm not saying yeah. I'll give all it.
Okay.
Right? But yeah, real easy. Well, a question real quick. Right? So this is position vectors. Pretty easy stuff. Anybody find this hard?
Not really. That's all it not that confusing, but it normal. It's normal.
Okay, cool. Yeah, let me get a past paper question real quick. Should have over here. I'll give all of this question just now. By the way, guys, all you see this form here? This form, this form over here, this is referred to as a column vector form. Should probably write it down here. So this over here is a column vector form. We just change this here to column vector form. So just make that change, guys. This is a column vector form. Let me know when I make that change, right? Column vector form. So anytime you see column vector form, this is what they are talking about. Anybody confused? Guys, everybody's
Nah,
really quiet.
yeah, I change it though.
Wait, somebody leave? I have one less person in class. Who's that person? Amy was
Yeah.
Ali in class.
I'm not sure. I think Kiara left because she said that she phone or something was overheating.
Oh my.
But she will join back though. So
Okay, cool. Um, I hope Alicia don't pull the same thing again. You know. Hmm. Amy, go talk to Alicia, right?
yeah.
Mm-hmm. Right. Okay. Right. Got a question. Yeah, I wanted to try this question here for me. Write O to R as a column vector. For those who did not get it, a column vector is the form I would have taught you all just now. That's where you put the horizontal movement first, then the vertical movement. Let's try this question. Yeah, as soon as I finish working, son, mate, just like this, I should take like 1 minute for this. This is an easy one. O to R. O to R.
I must be missing something because there's only one line.
Yeah, it's literally one line. It don't have nothing to it. Real simple.
I'm saying that day.
Yeah, that's correct. Real easy.
Word.
Um, Bryce, you have an answer for me?
Kind of way, yeah.
No kind of way. You're supposed to get this one. Because we did examples and we looked at the concept. Should be good to go.
Well, I guess what I have in my head probably correct then.
Right on the answer and send it to
I'll send you a picture. Yeah, I'll send you a picture.
Yeah, that's correct, Amy. Sasha, I wanna get answer as well. Keely, Kirsten, am I missing anybody?
Rishi, if you could just scroll up back for like 2 seconds.
Scroll up back.
Yeah.
Give me on previous one.
Yeah.
So I would have explained. You see the parts where you see the parts where I explain what the column vector is?
Mm-hmm.
That's where you have the horizontal movement first and the vertical movement. So let me just say, well, by the way, we deal with position vectors right now. That just means we starting from the origin. So if I want to go from O to A, that means I have to move 4 spaces to my right and then 3 spaces up. So to write that as a vector, I would say 4, 3 in the column vector form. You understand that?
Yeah, I understand. I just wanted to see the example.
Oh, okay.
Yeah.
Yeah.
Okay. That.
Wait, what? Bryce, tell me how that working. I want you to tell me how that working. Because I kind of confused by the answer. Little. Tell me how that working out.
Because it's like it going up and like it's literally like just one ooh,
Is it 8 going up?
yeah, it
What do you mean 8 going up?
even though it like 8 blocks going up.
No, you don't do it like that.
Because you do it on the number.
Look at the example. If I want to go from O to A, what I have to do?
Um you gotta go positive first. Okay, so you're going right and then you're going up.
Right. For this one, we had to do what? If I want to go from O to B.
You have to go left and then go up.
Right. Over here, if I want to go from O to R, how I do now?
Um oh, okay, I understand. Yeah, I think I do it okay. Is
Yeah.
is -1,
-1 then.
then 4.
Yeah, that's it. That's
Shucks way.
right. Cool.
I didn't even know why it is a son on I want you. I didn't even know. I saw something, whatever. But yeah, I didn't even know why.
I'm waiting for answer from Sasha and Haley. Haley, do you understand this?
Yeah. I just got mixed up just now. But
Yeah, I understand.
Sasha, I didn't get an answer.
Yeah, I understand.
No, but I did not get an answer. I didn't
Oh,
see written, working, didn't see an answer.
hold on, I was saying it.
Rihanna, you said that early. Wow. Nice. Yeah, Rihanna, that's correct. I just forget how much people let's have in the maths class, boys. We are like, wow. Have like 11 people or something. So yeah. Alicia, I see Real back on all day, but it's good that you
Hello.
joined. It's good that you
Yeah.
joined. Nice, nice. You really wouldn't be too lost. We didn't do anything that hard. Real simple stuff.
Okay,
Yeah,
I'll rewatch the recording after.
no problem. Um, Sasha, I want you to do it with me here. So let me just Okay, Haley, that's wrong. I want you to pay attention to something. When we are writing it in the column vector form, it's always the horizontal movement first, then the vertical movement. Always. You hear that, Haley?
Yeah.
So, if I want to go from O to R, tell me what I have to do horizontally. How moving? Left or right? If I want to go from O to R. Don't overthink it. O to R. How much I had to go to the left or to the right? Haley?
You have to go to the right.
To the right, but then if you go into the right and then you move up, or even if you move down, that's real far away from R. That don't make sense.
Hmm.
You have to move to the left. Check it out. We're gonna move one space to the left, and then
Oh
we're
my
gonna,
God. Oh my God. Sorry. Okay. No, no, wait.
you understand?
Yeah.
Alicia, you understand that, right? If I want to go from O to R, I would move one space to my left, and then I would move four spaces up. You lost, so you
Yeah.
understand that.
Mm-hmm.
And since I'm moving to my left, it's positive or negative?
Negative.
Right, so one space to the left, and then four spaces up. So anytime we're going up, that's a plus. Anytime we're going to the left, that's a minus. So when I'm writing it in column vector form looks like this. It is X and Y. X is your horizontal movement. You always state your horizontal movement first, and Y is your vertical movement. You always state that secondly. So if I want to write O to R would be equal to what, Haley? Tell me. What was my movement?
Would
Horizontal.
be -1/4.
Yes. That's it.
I was watching the wrong thing.
I sent you the picture, by the way.
Okay, let me check it.
Rajiv, I sent you my answer since 8:09.
I check your answer. I say it was correct.
No, you didn't tell me it was correct.
Well,
Unless you say it in your mind.
no, I remember saying it was correct. But that's okay. So here what guys, we know what a vector is. We know what a position vector is. We know how to write a vector. Let's look at a harder situation where we don't have a position vector, but we still want to go from a point to a point. It will be fine. Trust. So we know what a position vector is. Let me check off some stuff. So we know what a vector is. Um, you know what a position vector is, right? Should I do it in that order of thinking? Since you all understand this concept, I don't see why Ali wouldn't understand this concept, which is examples that do not involve position vectors. So just remind me, guys, if you have a position vector, where do you start from? If you're a position vector, where are you starting from? Could somebody remind me? Like where are you
The
starting from?
origin,
You're starting from 0, 0, and then you're moving either left, right, up, or down, right? So if something is not a position vector, then where would it start? If something is not a position vector, where would it start? Somebody make a guess. Healy, I want you to figure it out. If a position vector is a vector that starts off at the origin, what do you think a vector that isn't a position vector starts from? Let me ask you a question, Healy. Do you have to start off at 0, 0? Like, let me ask you a question. Does everybody live in Penal? Healy, answer my question. Does everybody live in Penal? Like everybody in Trinidad? Does everybody live in Penal? Can I hear in Healy? Amy, does everybody live in Penal?
No.
No, people could live in other places.
Yeah.
So I want others to think of Trinidad as a vector space. Trinidad is a vector space. And in Trinidad, you have people live in all different locations. So, simply put, where somebody lives is where they're starting from, right? Like if I live in San Fernando and I had to go Pina, I'm starting from San Fernando and I go in Pina. If I live in Port of Spain and I want to go Arima, Port of Spain to Arima. So, you don't have to start at the origin. You can start anywhere over here. Amy, does that make sense? I can start at any point in the vector space. I don't have to start over here. Tell me that makes sense.
Yeah.
Okay. Sasha, that making sense?
Yeah.
So Sasha, let me just say I start at 3, 1 instead. Let me just say I start over here at this point and I want to go to this point over here.
Okay.
How are you doing that? So let me just call this point R and let me just call this point Q. No, let me use Q, let me use T. How would I go from R to T?
Um,
How
I
much
would
space is
go
how to move?
2 spaces to my right and then 2 spaces up.
But look at the scale. 2 spaces really represents what?
Well, 1
Right? So 1. So I move 1 to the right and then
to the up.
right. So Sasha, in doing that, I went from what point to what point? I went from where to where?
You went to R to T.
Right. So that vector, I would write that vector as R to T. And that makes sense? Because I'm
Yeah.
starting from R and I want to go to T. And the instructions was if I want to go from R to T, I take 1 to the right and then 1 up. So my vector for that will be RT is equal to 1, 1. How does that sound?
Good.
Cool. Let me give you a formal example. Because I feel like I lost some earlier. I feel. Nicholas, you understand that, right?
Yeah, of course.
Right. Rihanna, you understand the concept?
Yeah.
So Bryce, you understand what I mean, right? Not everybody does live in Trinidad. I mean, not everybody does live in Pina. And there are some people that live in Sando, Arima, Darwood.
yeah,
Right. So and everybody, if they want to go to somewhere, and everybody would start at a different location.
yeah,
Yeah, so think of You see this space over here? You see this? Think of this like Trinidad. And
Okay.
you could have people living here, 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 here. You understand what I mean, right?
Yeah. I want to go
And
to my arrow though.
all right, that's a good example. Let me just say, Bryce, you living over here, and you want to go to Mayaro, which is like deep, deep south. So let me just say that's over here.
Yeah, which one that was again? Wow. Okay.
So Bryce, a little harder, right? Making it a little harder. Max, that question: did you start off from the
Yeah.
origin? Did you start from the origin? Where are you starting from? What's the point you're starting from?
B.
Read off the point from a
Um, 3.
tree, comma,
Um, 3, comma 3.
right. And you want to go to point M, which is my arrow. Read off that point from
Yeah. 7, comma -7.
Cool. So you definitely not starting at the center or the origin.
Nah.
No, because that makes sense. Everybody could live in a different place. Okay.
Yeah.
So tell me, how are you going to go from B to M? Describe for me the movements.
All right. So,
Wait, and if we want to go from B to M, I would connect them and I would draw an arrow going in what direction?
oh,
Okay.
yeah. So,
Would I
you
draw the
gotta
arrow
go.
like this?
Nah.
Nah. I would
Next
write
side.
it like this.
Yeah. Yeah. So is 2 to your left.
Let me see if that's true. 1, 2. Wait. So you
No,
say
next
two to
side.
my left. That would be 3, 4, being 5. Hmm.
No. Oh, shucks. Sorry. To my right. Sorry. To my right.
So you're saying 2. That'll be 1, that'll be 2.
No, next side. Dad. Next side.
This side?
Yeah. And this later.
No. If you want to go,
Oh,
you want to go from here to here. And you wanna say you wanna move left or right first. How you gonna move? You gonna move left or right first.
um, I guess you move. Right.
Don't overthink it. You go into the right. How much space do you
Yeah,
say
but
right you think
three
you have?
spaces. 3.
3, let me see. So I starting off by 3. 1, 2, 3. I'll go end up by 6. But I wanna go by 7.
What, 4? Oh, I thought you started from the point. Oh, the point is from 3. Oh, okay, okay, okay.
Right? So I would have moved. How much spaces is that? That's 4, right?
Yeah,
That's 4 spaces to my what? Left or right?
right.
And then I move how much spaces?
Down.
Yeah. Because you can move down next, right? That makes sense. Perfect sense. How much spaces are moving down?
7.
Right. Am I really though? Let me check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
10 spaces.
Mhm. So you had to move 10 spaces down. So the answer for that, if you want to go from B to M, what's the vector? What would the vector for that look like? B to M is equal to
4 over 10.
nah. You went down. You went down. So I'll be 4.
Oh, 4 negative 10.
Right, 4 negative 10. And this is a little bit of this is like a zoom into the future. This is what they will learn just now.
The
You could also use it using the triangular rule of vectors. You all will learn this in the future, but I just write any work in one time. If I want to go from B to M, that will be equal to B to O plus O to M, which is equal to minus O to B plus O to M. So I'll be minus 3, 3. Don't worry with this working, it will make sense in the end. In the end, it will make sense. So I'm going to end up with minus 3 plus 7 minus 3 minus 7. You're going to end up with minus 3 plus 7 is 4, 4 minus 10. So Bryce, which one looking easier? Reading it off the diagram or the calculations?
You could repeat back what you see.
Which one look
My
which
efforts follow them.
which looking easier? The calculations or just reading it from the diagram?
Those are
Which method looks easier? Reading it from the diagram or doing the calculations?
doing the calculations.
Yeah, you mad. I didn't even understand
How?
calculations yet. I didn't even understand the calculations as yet. This is just like
Well, right,
it's
is,
like a
but just even
preview.
with all the big that are working, that one looking much more easier. But yeah,
This one over here.
yeah,
Yeah, you read off the diagram. That's how you get the answer.
yeah, that is the best one out of
Cool.
all.
So let me give all that question to do then on this. Past paper question. Again. We are gonna take the same question and change it up a little bit. So here what? Instead of writing O to R, I want to let it tell me how to go from Q to R. Yeah, I want you all to tell me how to go from Q to R. Yeah, don't use any calculations or anything, as I don't know the calculations for it as yet, right? But I want a letter from the diagram. Tell me how you would go from Q to R. So Alicia, you go do the question one more. What are we doing this on the board? So I explain exactly
Okay.
what. On a scale to 1 to 10, how lost are you?
Like a 6 or 7, but it was only because I wasn't here for the first half. But when I rewatch the thing, I will understand.
Okay, nice. I mean, when I do the question, I want you to go make perfect sense story.
Okay.
So from this diagram, I want you all to tell me how how would we go from Q to R? I want to see just a column vector. I should probably put it right here with the example so I could use the example. Yeah, that make more sense. So write QR as a column vector. I want you all to find for Q to R. How are we gonna go from Q to R? Hmm. Given it 3 minutes, it shouldn't take that long. Kira, are you lost? Kira, let me know if you're lost. Or you're like, you understand. Is Kira in class, guys? I guess not. Uh, let me check where you have the Amy. Amy, you make a rookie mistake. Rookie mistake. You want me to tell you was your rookie mistake?
Okay.
The scale. Scale is a mistake. Check back your scale.
Oh. Oh no, I don't notice. Okay.
I see Nicholas realize that too. I see you scratch it too.
Yeah.
Mm. And it would seem that we have a winner. Yeah. Big up yourself, Rihanna. That's correct. Yeah, big up yourself, Amy. That's also correct. And Nicholas, I think you have it. Just send me back the answer, there. What's up if you have it.
All right.
So Bryce and Sasha, I feel like I'll lose all your attention. Look at the diagram and see how you would go from Q to R. See how they would go from Q to R. What you had to do. Remember, you're moving left or right first. That's the first thing. Moving left or right. Yes, Sasha, that's correct. That's correct. Nice, nice, nice.
I feel like my teacher was like teaching it, right? But then, like, I'll tell you, he just write it down on the board and he don't say nothing. And like, you don't understand thing.
Wait now, so Herman really teach all this?
I feel like he writes down on the board and just we didn't bother with him because you know how he doesn't explain anything at all. So like,
Yeah.
yeah.
Was Herman actually doing something now then?
Yeah, he get cut out by the principal. I'm thinking,
Wow, that's good.
So Bryce, if Sasha could get it, I think you should get it as well. How would you go from
Yeah.
Q to R? You had to tell me.
Um,
How are we gonna move?
you go into your
Yeah,
left.
that's correct. Nice.
Yeah, go into your left.
Yeah, how to go to my left? How much space is to the left? Wait, before you say anything, write it down in a book, see if you can figure it out. I said I send my picture. Keely, let me know if you understand what's going on.
Yeah, I think so.
You sure?
Yeah.
I will wait for an answer. Answer in the form of a picture from Haley and Bryce.
And mine correct, yeah?
Yeah, Nicholas, yours is correct. You didn't have to write the X and the Y. It's correct.
Well, I feel like I write too little bit now, so I just wanted to follow a little more.
Oh. Right, so the next thing I'm going to teach you all, which is just now, is the triangular rule of vectors. You all know how to deal with diagram like a boss. Now I want to show you all how the calculations work. I'll show you all that. Yeah. Remind me, guys, the next thing I had to do too, what happens when you change the direction? So Sasha, when you change direction, what happened to the sign? Do you recall what happened to the sign when you change direction? If positive is to the left, then the right is,
the right is positive and the left is negative.
yeah, I mix it up. That was just an arbitrary example. But using all you know so far, the left, if you go in the left is negative, right? Left is negative. So your right will be positive because you're going in the opposite direction. So anytime you change direction, what happens to the sign? So left is negative, and when it went to the right, it was positive. So what happened to the sign?
It changes.
Right. Anytime you change direction, you change the sign. You'll need to know that just now. When we do in triangular rule of vectors. Bryce and Healy, do you all have an answer for me? By the way, Kiara, I said the answer was correct, eh? I said the answer was correct.
I hear this time.
Okay. Just making sure.
Yeah, I'll answer your picture. No.
Okay.
Yeah.
Oh, listen, man, anything, just keep in mind, there's a scale here. Every 2 blocks is actually 1. Wait, Bryce. Yeah, that is correct. We make a little mistake though. Are we going from O to R? Where are we going from? Where are we going from?
Sorry, is Kika R. Sorry, I
Where's,
mix it up.
where's the arrow? Arrow is important. That suggests the direction they're going in.
Yeah.
Right? I just waiting for my answer. Waiting for answer from Healy. Healy, are you there? Guys, is Haley in class?
No.
Yeah.
Oh, yeah.
Okay, Haley, you say you would like me to explain it to you. Sure, no problem. So Alicia and Haley, I wanted to unmute. I'm gonna explain it to the both of you guys. Right?
Okay.
Right. So I'll both of you stay unmuted. And they could probably talk to each other as well.
Haley Raven unmuted.
I am.
Okay,
Oh,
both of you
really?
are unmuted. Nice. Nice.
Okay.
So if we look at the example, if I want to go from Q, wait,
And
this,
that's supposed to be B, Reggie.
oh, yeah, this was to be B or Q, whatever the case is. But let me just write this as B. That'll make things less confusing. Rather, I have to change over everything here. So B to M. So Haley and Alicia. If I want to go from B to M according to my draw, I would have to take 4 spaces to my right, and then I would have to move 10 spaces down.
Right.
Alicia and Haley, that confuse all you?
No.
No.
And let me look at a simpler scenario. Simpler scenario with position vectors. If you're dealing with position vectors, the same concept. We're just starting from O. So if I want to go from O to A, tell me, Alicia, if I want to go from O to A, how I do that?
And 4 spaces to the right, and then 3 spaces up.
Right. Haley, if I want to go from O to B, how I do that? I want to go from O to B. Haley, how would I go from O to B? Tell me that confusing you. How am I
So
going
I think
from
she internet give in trouble because it look like she just leaves because she keep leaving and joining back. So I think she internet probably give her in trouble. Or it's
That is,
either she audio.
that's probably why she don't understand if she intended to get in trouble to keep on
Yeah, like
flipping.
she now joining back.
Okay. Yeah, Haley. Um,
Can you hear me?
yes.
Okay.
Tell me how I would go from O to B. We starting from O and we want to go to B. We're going from O to B.
You go 4 spaces to the left.
And then we go move up 5.
Yeah.
Notice we always starting off with left or right. We always, that's the standard. That you always have to do that. Don't make that mistake. So if I want to go from Q to R, where am I starting from? Q to R, where am I starting from?
5? What? You mean like go how much you going out?
Nah, I mean the point. Where we starting at? I
It's
thought that QR.
minus
Oh,
I
minus
thought
1.
who said -1?
I was thinking 5 or like 5 2.
Yes, 5 2. Um, Healy, that confusing, yeah. Q to R.
E. Yeah.
Q to R. That means you're going from Q, you're going from point Q to R. So where you starting from?
Q.
Starting from Q. So you're going from Q to R. From Q to R. Look at this example. B to M are going from B to M. You're confused by that?
No.
Yeah. You okay with that, right?
Yeah.
So we starting off at what point? Is it R or Q?
Q.
Starting off at Q. By the way, guys, point Q is given by what point? Q is what point? Read off that point from her. Q. Point Q is what? Read off the graph.
5 2.
Yeah, that's 5, 2. And while we at it, let me read off R. What is R? Thelma, Haley, what is point R if you read off the coordinates? If I read off the coordinates for R, Thelma, Haley. Haley, let me know if you're hearing me. Say something.
You're here now.
Yeah, hearing you.
What did you ask?
Yeah, I want you to tell me the point for R. The point as a coordinate.
Is it -1?
-1, comma.
Um, -2? -2? 1?
-1, comma 4.
Okay.
Tell me, how you confuse that? I don't judge you or anything. I just want to understand what's going on.
Honestly, for a second, I was counting the block.
No, I don't have to count the blocks because it had 4. Watch. R is -1 here and 4 here. So -1, comma 4. Let me just make sure you understand that real quick. Could you read off this point for me?
Yeah,
What's that point?
that is -2. And then comma 1.
Cool. Yeah, you understand that. So going from Q to R, tell me, how would we move? We always starting off with horizontal movement. How am I going to move horizontally? How much spaces am I going to move horizontally?
-1. Oh, sorry.
Wouldn't be -1. How much spaces would I have to move from Q to end up at R?
Oh,
And you can
You're
count the blocks.
gonna
You can count the blocks with me. So we're going to move to the left or to the right? Haley or Alicia? Any one of you
oh
guys?
you move in to the right. You're counting from Q to R, if that makes sense. Like you're counting from the 5 to the -1.
Yes, but how you say it is wrong. If I go in this direction, that's to the left. Instead of going to the
Mm-hmm.
right.
Oh shucks. Okay.
So if I want to go from Q to R, I have to move in this direction first,
Yeah.
and then Haley, what I have to do next? I have to move in what direction next?
the vertical.
Right, vertical. So describe the momentum. Are we moving down and moving up? How are we going to go to R?
We moving up.
Moving up, right. So let me describe the movements. I moved. We could count the blocks and then divide by 2 because we know that 2 blocks is 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we had 12 blocks and 2 blocks is 1, right? So how much that is really? We have
6.
12 blocks and every 2 is 1. 6, right?
Yeah.
We move in 6 to the left or 6 to the right.
6 to the left.
So anytime we move to the left, what sign is that?
Negative.
Minus.
Right. And we move in how much spaces up? 1, 2, 3, 4. 4 divided by 2, 2. Moving 2 up.
Hi.
So guys, if I want to go from Q
Right.
to R, if I want to go from Q to R, how much spaces we move horizontally?
-6.
Right? -6. And we had to put in the vertical movement. The vertical movement in this case was 2 up. So 2. That's the answer. -6, 2. So you understand that now?
Yes.
Alicia, you understand it? Healy, you understand it?
Yeah.
Okay. I'm gonna I'm gonna give only one question. Next class, I'll move on to triangular ruler vectors. Do some questions there. We will look at resultant vectors. Then we're gonna move on to magnitude, units, scalar, them kind of thing. But learn how to get this concept down. And give away our next question. And everybody could do this question. Yeah, so guys, I want you all to tell me how I would go from P to R. How would I go from P to R? Forget about this Q1 thing. Yes, Selma. How would I go from P to R? How I doing that? How am I gonna go from P to R? Remember, Keely, you always count what movement first. Vertical or horizontal movement.
Horizontal.
Right, so you're gonna move horizontally first, and then you're gonna move vertically. So guys, take some time and figure out how you're gonna go from P to R without doing triangular ruler vectors.
So is it 3/8?
Say that again?
3/8.
3/8.
Yeah.
So you're telling me if I want to go from P to R, you're telling me how to go three to my right and then 8 up.
Yeah.
Let me see.
So yeah, the
You,
answer.
so you telling me if I want to go from P, I starting from P and I go into R. Yeah.
Yeah.
Okay, let me move according to where it's up now. I starting here. I'm moving 3, 1, 2, 3, and I'm moving
Oh, wait. Nah. Sorry,
4,
I do it
5,
wrong.
6, 7,
I
8.
do it wrong.
That'll be
Nah,
quite
I
a
do it
layer.
wrong. Yeah, but I do it wrong. I put the Q in it now. So, yeah.
Giving people wrong directions, man. Oh God, boy.
Sorry.
Okay, let me check what Amy said. No. Yeah, Amy, that's correct. Nice. Sasha, I make one mistake. Yeah, one mistake. That um the vertical component is wrong. Would not be 3. Wouldn't be 3.
Okay. Check.
Yeah, Alicia. So you see, you're not lost at all. The answer is 7. Oh shit.
No, it's not 3. It's
Yeah,
2.
Alicia. So this really is the answer.
It is.
Yeah. Um, Bryce, take your time and try back. Healy, go on if you're getting through.
Sorry, what did you ask?
Yeah, ask if you're getting through.
Yeah, I'm not gonna start it. I was doing something.
Okay. Yes, Sasha, that's correct. Nicholas, you know what the answer is?
7/2.
Put it. Yes, tell everybody the answer.
Oh shucks. Are you done yet?
No,
Oh go ahead.
Nicholas is supposed to stand limit.
Oh gosh.
Nicholas, not everybody intellectually able like you, know.
Oh Lord. Ah,
Yes.
sorry. Yeah, I get him my next question. Just fine.
Okay, I will do that. Playboy Nicholas. Throw things off bad day, boy. Hey. Them girls will come on strong any night.
That is pressure.
Yes, I want Ali to tell me how to go from W to Y. How are we gonna go from W to Y? W to Y. And I also want to let Selma how to go from Y The W. Mm-hmm. This is because of Nicholas, guy. Just remember that. This is because of Nicholas. This is all Nicholas.
Yeah, I take in full responsibility for that day. Or you should thank me for giving all your next question to practice.
Right. So I'm waiting for answers to just pour in. Send the answers. I want to go from W to Y. So Nicholas, you have to do the question as well.
Yeah, I don't finish.
Oh God, you're flexing now. You're flexing. You're bad. You're bad. Yeah, so Healy, I need to hear an answer from you. I have to make sure you understand this. Rihanna has been awfully quiet. It's scary.
All right here.
You understand all this, right?
Yeah.
Lovely. Lovely.
What?
Yeah, Amy, that's correct. And I want you to write YW from now. You're gonna notice something interesting happening.
What to find hope?
You gotta find for vector W to Y. How are you going from W to Y? And when you finish with that, find Y to W.
Okay.
So Nicholas, you notice a pattern between WY and YW?
Yeah.
Yeah. We're gonna talk about the pattern after. When everybody get. Amy, you see the pattern, right?
Yep.
Right. Just keep in mind what I say about direction. When you change direction, you also change. Mhm. Right, Kira, do you notice the pattern?
Yeah, I seen it.
Nice. I'm preparing only for the next class, which is triangular ruler vectors. We're gonna look at how to do it without diagrams. Calculation strictly. I'm waiting, I'm waiting for answer from Haley, Bryce, Alicia.
I spelled my name wrong.
Who? Who's Haley? Sorry. Hailey. Um, yeah, Haley, Bryce, and Alicia, and Sasha.
I know, yeah.
Yeah, that's correct. So Alicia get it correct. Alicia, you see the pattern there?
Yes.
Cool. Sasha, Haley, and Bryce, I like you get it. Haley, you understand what's going on? Sasha, Amma,
I don't think that's correct though.
isn't correct because if I follow them instructions, things will go crazy. Let me explain. So you saying if I want to go from W to Y, I had to take 112, which means I had to move one. So I'm moving one to the right, according to the instructions, and then I'm moving 12 up.
Wait, no. Sorry.
So why over here then? That way carrying, man.
Nah.
Rihanna, that is correct. Do you notice? No, actually, no, Rihanna. You do something wrong. YW is wrong. YW is wrong. Remember, it's always the horizontal, then the vertical. Just keep that in mind, Rihanna. You're moving the horizontal,
Sorry.
then you're moving vertically. Bryce, I'm not hearing from you. I'm not hearing from Celie. Bryce, are you with us? Okay, Bryce is not with us. Keely, are you with us?
Yeah.
Okay. So QR, we starting off from where? Which point we starting off from? Haley? I mean W. Yeah, W to Y. We starting off from W to Y. Listen?
You're talking to me?
Yeah.
Why?
You say we starting off from Y,
Sorry, W.
right? Because it's W to Y. Yeah. So see if you can figure that out. Yes, Asha. Some of the correct answer. Haley, you having some trouble with the question?
Yeah.
What giving you trouble?
I can message it.
Yeah.
Okay.
Yeah, that's correct, Haley. So you have the horizontal movement, correct? Now you need to figure out the vertical movement. Yeah, so Sasha is sound back the correct answer.
Hold on. Let me check correct here.
All right. If you need to, count on the screen. If your directions leading you to somewhere other than here, then you're doing something wrong. You had to go when you take your directions, you had to reach up here. You had to reach there. Um, so Bryce down for the count. So I'm just looking at mainly Haley and Sasha. So Haley, you tell me the horizontal movement. What is the vertical movement? So after you move that amount of spaces, how much more spaces you have to move up or down to reach the Y? Haley? Yeah, so after you move that amount of spaces, no. Watch. Haley, let me show you why that wouldn't work. If you move 11 horizontally, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you're saying to move 11 horizontally and vertically. So you're saying after I reach over here to move 1, 2, 3, 4, 5, 6, 7, and be quite over here. Is that where Y is?
No.
No. So after we move 11 spaces, what how to do next to reach Y?
Go down one.
Yep, that's it.
That's it?
That's all.
What?
So if I want to go, I want to go from W to Y, I would move 11 spaces. I would move 11 spaces to my right, and then I would move one space down. Sasha and Healy, let me probably catch that. So we're gonna move 11
Yeah.
spaces, 11 spaces to the right, and then we would move one
One.
space down. And this is the last thing we do for class today. I'll give all you some homework. Healy and Sasha, you have to do that homework. I need to do that homework.
I was gonna ask for who.
Okay, nice. So if we're moving to the right, it is positive. If we're moving down, it's negative. So my answer for W to Y is, tell me, it is a column vector. X is 11, then what? Tell me, Haley, 11 what?
11-1. Sorry, my Wi-Fi again.
Minus what?
What?
Yeah, because you had to go down.
Oh, yeah, sorry.
Yeah. Right? Let we look at our same question, but wait. But let we answer it now for W. I mean, it's Y to W. Right. Right. So Haley and Sasha, all you had to get this rounds. right? So we're doing the same thing, but just in the opposite direction. That's what we're doing. Um, change the layout of this thing and it annoying. Okay. Yeah. So instead of going from W to Y, now I want to go from Y to W. So Y to W. So where am I starting from now? Healy, Y to W. Where am I starting from now?
It's starting from Y.
I'm starting from Y and I want to go to W. Would it have the same size? Like, are you traveling the same distance?
Yeah,
It just, what was the only thing that
negative.
changing? What's the only thing that changing?
The the sign, it become a negative.
Well, that's because we changed direction, right? And that's
The
that's
Y
because we
and the
changed
W
direction.
changing.
Watch. Over here was W to Y, now it's Y to W. We changed direction. You understand that?
Except that.
Okay, nice. So let we count. If I starting from Y, how would I go? How would I end up at W? Somehow how do that?
You have to come deeper.
What direction I going in? I want to end up at W.
You're going horizontal to the left.
To the left. How much space is to the left?
11.
Right? And Sasha, what do we next? After I move 11 spaces to the left, what do we next?
You move in one space up.
Right, so we go in 11 spaces left. Anytime we go into the left direction, what is the sign?
Negative.
Negative. And then we're gonna go, like you all told me, one space up. And if I go in one up, that's positive. Cool. So where's the vector for that then? That's equal to what? Tell me the vector.
Hello.
Yeah, tell me the vector. So Y to W, that'll be equal to,
Me,
yeah, anybody.
it'll be minus 11 over 1.
Now, what I want you to notice is that, okay, we have WY, right? WY is 11 minus 1. And the funny thing is, W to Y is the same thing, you know. It just changed the sign. Minus 11, 1. Anybody else notice that?
That was a pattern you was raving about.
Yeah. So in other words, I could say, what's what I could say, right? I could say that WY, I could say that WY is the exact same vector as minus YW. Or I could say YW is the exact same vector as minus WY. Let us soak in for a little bit. Both of the vectors is the same size, just different direction. Now, anytime you're going in a different direction, you change the sign, and you would have noticed that Y to W is 11 minus 1. However, I said Y to W just now, my bad. W to Y is 11 minus 1. But if you're going in the opposite direction, it's now negative 11, 1. That's because you're going in the opposite direction, so it changes sign. Same thing you're seeing here. W to Y is the same thing as YW, just in the opposite direction, for the negative sign. Clearly, you understand that?
Yes.
Now, Y to W, and I can say that is the same thing as the opposite of WY,
Yeah.
because then YW is the opposite direction to WY.
Yeah.
and to represent that upon negative sign, right?
Mm-hmm.
Yeah. So Alia, have a good footing. Next class, we're gonna look at triangular ruler vectors and do some harder past paper questions. Everybody okay, right?
Mm-hmm.
Nice. I surprised everybody stay, minus Bryce. Alicia, let me know if you understand this concept. How you feeling?
Yeah, I do.
Okay, cool.
It's
So
not as hard as I thought it would be.
real easy, ends.
Yeah, but I feel like I still need to go through the recording still, just to make sure to lock it in now.
Yeah. We had a lock in. We had a lock team. I will try to send you recordings immediately after class. Just like now. I'll see if I could do it.
Okay.
Right? So anytime you change direction, what happens to your sign? What you noticing happen,
Changes
the sign changes.
to the opposite.
Yes, exactly. And that's the main thing I want you to take away. The reason why I show you how to do it on the graph is so that I can work smart. A student who does not know how to use the graph will go and do this calculation. They will do this calculation even if the graph is in front of them. That's all, yeah? Would all ever do that?
Mhm.
If the graph is in front of you, why are they doing this calculation for? Until they could just read it off the graph and move along with all their life. Are they staying quiet? I kind of worried.
I'm
Ollie,
sleepy.
we had to work smart, can't work hard. Unless all they want to go bald. Men. Nicholas, you want to go bald?
Yeah, you ready?
Whoa. Kira, I think Nicholas would look good bald.
Absolutely not.
I didn't even know what Nicholas's look like.
I don't know
You
why.
say that every class.
I saw
I have
I saw
I
I
have
saw
some nice
Dustin.
pictures of Nicholas. I
Where's
should
that?
show him one.
Send
I
my
have some nice pictures of Nicholas.
send my picture. I'm real curious.
I
Pictures.
wouldn't know. Nicholas had to give my permission.
How long ago them pictures is from?
It had me stick on my tire sent today.
No, that was last year. My hair was really short.
I will see what I have.
I imagining like he's look like Snoop Dogg.
I'm gonna send you a picture.
No.
I feel like this look like Snoop Dogg too. I'll send you a picture now. A normal, unfiltered picture.
Okay. And this one right in here is a big note. Note. Why it's so big?
I think I just look like Vector.
I don't want to be saying that. Trust me, I don't want to be saying that. I don't know why you're saying that.
I think so.
Right? Working. So we have it working here. We send any chat?
I'll send it in your chat.
Oh, it's and this over here is so Rihanna, you're not gay, right? You ready to mash up the scene?
Huh?
You ready to mash up the scene, right?
Probably.
See this negative attitude? Stop it.
No, it's not a negative attitude. It's a sleepy attitude.
Ah, I see.
I don't wake up early in the morning, so
Well, let me end class now. Right? Let me just check that picture and Give a reaction. What? That is Nicholas? What? Ain't no way.
I tell you, this look like Vector.
I was not expecting that at all. What? That's you look
I
like
should
someone.
say,
You look like a Matthew.
Matthew.
Yeah.
It have a man named Matthias that is get compared to.
Mm. Okay. I don't know. I don't think I know Matthias.
Now you wouldn't know him. But teachers just think he's my brother because we just look similar.
You could probably tell him to come to the maths class for
I'll
fun.
tell him.
Yeah. Yeah. Well, guys, that's it for class today. I well tired. Um, I go on there. Have a good night, everybody. Later.
You too.
Yeah.
Bye bye.